A pyrophoric substance ignites spontaneously in air at below 55 degrees Celsius. Examples are iron sulfide and many reactive metals including uranium. When powdered or thinly sliced, pyrophoric materials are often water-reactive as well and will ignite when they contact water or humid air. They can be handled safely in atmospheres of argon and nitrogen. Most pyrophoric fires should be extinguished with a Class D fire extinguisher for burning metals. Uses. The creation of sparks from metals is based on the pyrophoricity of small metal particles, and pyrophoric alloys are made for this purpose. This has certain uses. The sparking mechanisms in lighters and various toys. Using ferrocerium, starting fires without matches. Using a fire steel, the flintlock mechanism in firearms, and spark testing ferrous metals. Handling. Small amounts of pyrophoric liquids are often supplied in a glass bottle with a PTFE-lined septum. Larger amounts are supplied in metal tanks similar to gas cylinders, designed so a needle can fit through the valve opening. A syringe, carefully dried and flushed of air with an inert gas, is used to extract the liquid from its container. Pyrophoric solids require the use of a sealed glove box flushed with inert gas. Glove boxes are expensive and require maintenance. Thus, many pyrophoric solids are sold as solutions or dispersions in mineral oil or lighter hydrocarbon solvents. Mildly pyrophoric solids and sodium hydride can be handled in the air for brief periods of time, but the containers must be flushed with inert gas before storage. Pyrophoric materials. Solids: white phosphorus, the original phosphor, alkali metals, including the alloy NaK, finely divided metals, some metals and alloys in bulk form, alkylated metal alkoxides and non-metal halide silane, potassium graphite, metal hydrides, methane tellurol, an analog of methanol where tellurium replaces oxygen, partially or fully alkylated derivatives of metal and non-metal hydrides with a few exceptions. Copper fuel cell catalysts e.g., Cu, zinc oxide, aluminium oxide, Grignard reagents. Used hydrogenation catalysts such as palladium on carbon uranium nickel. Iron sulfide, often encountered in oil and gas facilities where corrosion products in steel plant equipment can ignite if exposed to air. Lead and carbon powders produced from decomposition of lead citrate. Uranium is pyrophoric, as shown in the disintegration of depleted uranium penetrator rounds into burning dust upon impact with the targets. In finely divided form it is readily ignitable, and uranium scrap from machining operations is subject to spontaneous ignition. The GBU-39 is an example of a bunker buster bomb where uranium is mentioned in the patent as a way to achieve an incendiary effect with pyrophoricity. Neptunium, plutonium, several compounds are pyrophoric, and it causes some of the most serious fires occurring in United States Department of Energy facilities. Petroleum hydrocarbon sludge. Liquids: diphosphane, metal organics of main group metals, triethylborane, terbutylithium, diethylzinc, triethylaluminium. Hydrazine is hypergolic with oxidants like dinitrogen tetroxide, but not truly pyrophoric. Gases: non-metal hydrides, metal carbonyls,